Hey everybody, we're back for video 2. This time we're going to look at calcium oxide. So let's just go through the text and the images a step at a time. So it says here calcium has 2 valence electrons weakly held and far from a core charge of +2. So how do we know that calcium has 2 valence electrons and a core charge of +2? Well, when you look at the periodic table, you'll notice that calcium right here is in group 2. So that means it has 2 valence electrons and a core charge of +2. That's where we get that information. How do we know that it's weakly held? Well, again, metals are weaklings when it comes to their electronegativity. Again, electronegativity increases up and to the right on the periodic table. Calcium here is over here on the left, so it's weakly electronegative. It's not going to hold its electrons very well. And on top of that, calcium is a pretty large atom, again because it's on the left-hand side of the periodic table, and it only has a core charge of +2. So you put those two things together, and it's just not very good at holding electrons. Okay. Oxygen, though, has 6 valence electrons, strongly held, and close to a core charge of +6. So again, oxygen over here is in group 6A, so that's how we know it has 6 valence electrons. You can see those 6 here in this diagram, and a core charge of +6, again because it's in group 6. How do we know they're strongly held? Well, oxygen again is on the right hand side and near the top, so it's strongly electronegative. The fact that it is a small atom, again the atomic size decreases from left to right across a period, so the fact that it's small, has a large core charge, gives it a great electronegativity. So it's going to hold those electrons strongly. And you can see here with the arrows, these 2 valence electrons from calcium are being stolen by oxygen. Oxygen has 6 valence electrons. It can have a maximum of 8, so it just needs 2 more. And it's going to get those from calcium. It's going to steal calcium's valence electrons. So calcium's valence electrons, again which are 2, are much more strongly attracted to oxygen's core. The negatively charged electrons of calcium are much more strongly attracted to a +6 core than a +2 core. Oxygen is more electronegative. So oxygen steals those 2 electrons. Calcium becomes a cation. So although it's not easily seen in the diagram, calcium ends up with a core charge of, so not a core charge, but an overall charge of +2. Again, it lost 2 negative electrons, so now it's +2. Oxygen got those 2 negative electrons, so its charge as an anion is now -2. Calcium becomes a cation. Oxygen becomes an anion, and they're going to be attracted to each other in a crystal lattice, like we saw in the first example with potassium bromide. Again, they're going to arrange themselves in a nice organized fashion so that the cations have anions surrounding them, and the anions have cations surrounding them, and you get this crystal lattice organization being produced. Okay, so we'll see you in the 3rd video. We'll deal with sodium chloride.